Hey everyone, this is Kendrick Coleman here, and today I'm going to show you something called the Vblock Systems Mid-Level tool. This is a tool that I've been actually building over the past year and a half or maybe 2 years, and I'm finally able to share it with the world. So overall, what is the Vblock Systems Mid-Level tool? Well, it gives us the ability to actually build a Vblock very dynamically. We can choose exactly which components we want and be able to display to a customer exactly what the interconnects and how the wiring topology actually works between the UCS components, between the Nexus components, between the EMC storage arrays, as well as the out-of-band management, as well as the virtual infrastructure. So what we're going to do is just quickly take a quick tour over the tool, see how it looks, and see how it works. Now, to be able to access this tool, you need to be either a VCE, EMC, Cisco, or VMware employee to be able to go here and go to the VCE portal /tech tools /midlevel. And from here you can actually access this site and you can download here as well as read all the important information on actually how to be able to build this. If you're within the VCE partner network, you can actually go to the VCE partner network. This is the VCE partner portal. Put in your username and password, log in. After you log in, you can actually find it at vc.com/partner/enablement/tools/midlevel. You can go ahead, it's the same exact information and the same exact download here. Now after you download this zip file, you're going to be seeing these components inside of here. So you'll see the screenshot that I actually have of an old version. There's the README file of everything that's actually inside of these websites, and here's the actual PDF itself. Now this PDF must be opened with Adobe Acrobat. You can't use the Windows 7 or the Mac OS X native PDF viewers because it can't render layers. Layers is actually what makes this all happen. So being able to specify which layers you want to actually build the Vblock of your choosing. So if we can see here on the left hand side, we see all these different folders of all the different kinds of Vblocks, and we can see all the different kinds of layers we can put on here. Now if I just choose a layer, it's not going to mean much because I don't have any kind of context or exactly how I'm building this. So as you can see, I'm actually playing with these I buttons to display which layers I want. And over here we can see on the right exactly how it's building all this. Now on the right hand side we have the key at the very bottom right hand sideways, so we can see 10 gig Ethernet versus 10 gig fiber channel over Ethernet versus 8 gig and then 1 gig Ethernet. And at the very bottom right corner is this nice large disclaimer legal got to put on there saying that essentially you do have the ability to build a Vblock that is not up to a VCE standard. And the idea is because what you need to be able to do is anybody within VCE, EMC, Cisco, or VMware, or within the VCE partner network has access to the advanced configuration tool. That's the quoting tool that allows you to actually build a Vblock and be able to quote it for a customer. Now, within that actually holds the logic of what an actual Vblock really is supposed to be. So this actually, you should be able to supplement this with your act configuration. So remember the configuration you chose within the advanced configuration tool, and then be able to display it inside of here. So let's go ahead, we'll build out two Vblocks. We'll build out a pretty standard one, and we'll build out one that has a flexible architecture to it. So we'll build out a small Vblock 100. So within here we can actually choose our base. So we want a VNXE 3300. And we also want to make sure we'll have 6 servers in here. So we want to be able to, so we can see it first, the base of a VNXE 3300 is going to have 3 Cisco C220 servers in it. I'll go ahead and zoom in for you real quick as well. And if I scroll down, I can see there's my 3 C220 servers. I can see my Catalyst 3750s up here. I can see exactly I have the choice between 1 gig or 10 gig uplinks actually back into my customer network. So we'll go ahead and scroll back out here. We'll go back down at 50%. And then down here at the array itself in the VNXE 3300, I can see both of my storage processors and all the different kind of interconnects that are actually being used to go between all the different components here. So I can see there's a mix of 10 gig versus 1 gig pieces. So we can see that this is a IP only based Vblock. Now from here we can add additional servers. So if we have 6 servers or if we have 8 servers in our Vblock 100 here, we can be able to see this and be able to dynamically be able to show this to a customer. And at the very top, when you actually choose the type of Vblock you want, usually choosing the storage array, it's going to populate the title up here in the title bar. Now that we have that Vblock chosen, we can go down to the amp side and we can choose exactly which kind of amp we want. In a Vblock 100, I actually don't have the ability to choose a mini amp or an HA amp. That's just because that's not possible in regards to the advanced configuration tool. So I can choose my logical amp right here, and I can see that I have an ESXi hypervisor, essentially, which is going to be one of these servers inside of here, and I'm going to have all of these virtual machines running on side of it. Now, all these virtual machines within inside the amp all run different sorts of components. So if I scroll over, I can see exactly what each one's doing. In addition, I can also choose the virtualization layer, so I can choose my virtualization for the Vblock 100. Scroll down, and I can see this is what it's going to look like. It's a regular vSphere distributed switch, and from within here, I can see that I have onboard Ethernet and 4 expansion NIC ports. So it's not using any 10 gig Ethernet. It's all a 1 gig kind of infrastructure on the actual host themselves. Okay, so let's clear this and let's start over from scratch. So I basically just click the I buttons to remove everything that I had previously built. Now once I have that, I'll go ahead and shrink this down to a more reasonable size so we can see this being built out. Was it 33%? Let's make that 40%. That's a little bit better. So now let's go ahead and let's find it and choose a Vblock that's going to work in a more flexible configuration. So let's choose a Vblock System 320. First, what I need to do is I need to select my fabric interconnect type. So I have the choice of either 6248 or 6296. I'm going to go ahead and I'll choose a 6296. Now I can choose my chassis PERS domain and flexible uplinks. So within a Vblock System 320, you have the ability to actually have 2 chassis, 4 chassis, 8 chassis, or 16 chassis. Everything has to come in a few different pairs. By default, you usually have about 8 chassis in there. That's usually the default of what happens. Now you have the ability to actually have more flexible uplinks, so you can choose 8 uplinks. That's really for a high compute scenario. And you would actually have 8 flexible uplinks if you're using the 6296s. The 6248s wouldn't be able to handle that. So again, that's where you can actually stop yourself short in building an incorrect Vblock configuration. But by default, we usually have 4 flexible uplinks per FEX inside of each chassis. So that really relates to about 8 per chassis. Now that we have that per chassis domain, we can actually select our IP uplinks between our fabric interconnects and our Nexus switches. By default, we usually have 8 IP uplinks here. Now these 8 IP uplinks can also be expanded to 16, but that's really in a high compute sort of scenario. So let's go ahead, and now we can either choose, do we want a standard network or do we want a unified network? Now this is really where we choose, do we want to be able to have an MDS switch in here, or do we want to be able to use the Nexus 5500s to actually be able to do the fiber channel zoning for us? So let's do 2 of them real quick. So we say I'll choose our standard network using a 9148 with 4 fiber channel uplinks. Again, this is really bare minimum, the usual of what you're going to choose. And then I'm going to choose my standard network here, and I'm going to have a 7500 array in here. So at this point, I pretty much have my Vblock built. Now let's go ahead and let's say we want to make this a unified configuration. So in a unified configuration, we're going to go ahead and we're going to choose 5596s here because that's essentially what I want to be able to show. And I'm going to have 4 fiber channel uplinks going down into my into my fabric interconnects here. Then I'm going to choose the unified storage for the network array, and I'm going to choose the 7500 again. Now we can see those 7500, or so the 7500 is actually going up to the 5596s, and from there we can kind of see we have our Vblock built again. Now, of course, within here I have a real estate problem, and I can't actually show all of the links going up. So you'll see at times you'll see these numbers hovering over the amount of links. That's supposed to designate exactly how many links are actually going up into the specified components. Now I also have the ability to add unified. So if I have, as you can see right here, we want to add, say, 4 X blades. So I can actually have the ability to choose, put CIFs in here. And now I can actually have all these 10 gig Ethernet ports actually going up into our 5500s. And from there, we can then select additional cards because we can see By default, the 3 line cards that are in there probably aren't going to have enough horsepower or enough ports to actually be able to satisfy all these communication links. So from here, this is where ACT is actually going to be able to tell you, or the Advanced Configuration tool is going to tell you exactly where or how many other slots you're going to actually need populated. So looking at ACT is going to tell you exactly how many more slots are going to need to be populated so you can satisfy all these new types of connections actually going inside of there. Again, the 6296s, you might need more slots or more line cards in there if you're using more flexible uplinks. So now we have our Vblock chosen in this configuration. Let's go ahead and we can do the same things with our 720s, which is going to be the Vmax arrays, but you have a lot more capabilities and a lot more choices in regards to how many engines you want to actually show. In addition, inside the 320s, if you're using 6 or 8 X blades within the 7500s, you'll see that within over here, you shouldn't be choosing the 7500 with unified networking. You should actually choose the unified networking if you're actually using greater than or equal to 6 X blades, because you're going to actually be using a lot more NFS and CIFS power over here than you are actually going to be using block based. So we need to be able to reserve those ports for certain things. Now at the same time, we can choose our amp. And over here, we can choose our HA amp, so we can see our out-of-band management getting populated over here. We can see the 2 C220 servers, our Catalyst switches, and our VNXE 3150, as well as all the virtual machines that'll be running, as well as we can choose our virtualization layer. So if I drill down in here, I can see I now have our fabric extenders populated. So here's a better view of the HA amp. And then here is a view of the virtualization piece. So a Cisco UCS B-Series blade using the EMC PowerPath VE plugin allows multiple routes to go to all data stores, so you get greater I/O and greater throughput from your storage side, as well as all the the vSphere VM kernels, as well as the Nexus 1000V VIMs. How everything kind of looks and how everything kind of builds together, and how we're actually doing this all through the Cisco VIC through the port extender or the fabric extender as well. Again, since I'm at this deeper layer here, I can actually drill down. I can see all the different kinds of communications and all the different interconnects going between all the components inside my Vblock. I can see all the different, how many uplinks I actually have going to the customer LAN. And I'm also going to see that the AMP itself actually has connections into the 5596s as well as into the customer LAN as well. Now, I'll go ahead and scroll back out here. Now, if I want to add in replication with the EMC recover point, I actually have the ability to add in, remember choosing, did I have a standard network configuration using NDS 9148 or 9500 switches, or do I use a unified connection using 5596s? And I can choose, do I want EMC recover point appliances following the type of networking I want. Since I'm in unified, I can say I want to use 2 appliances here, and I can actually see exactly these 2 appliances being added. I can see their 1 gig bandwidth connections actually going into the AMP, into the 5596s, as well as the fiber channel connections. Now these fiber channel connections aren't showing the connections all the way into the 5596s, but instead it's actually showing this +2 right here. So it's saying we're going to add, so we have 1, 2, 3, 4, +2. So essentially we actually have 6 fiber channel links going up into the 5596s in this configuration. I hope this tutorial has been able to show you exactly how you can build your own Vblock based on the logic inside the Advanced Configuration tool. You can use this to be able to show to customers, be able to print this out and hang it on your own wall, really to show the dynamic capabilities of being able to map all of this out. If you have any questions, feel free to send me any questions at kendrick.coleman@vce.com. I'm the one who owns and maintains this tool, and I'll hopefully be able to add more features and more features into future integrations. Thanks and have a great day.